Welcome back. We're continuing with our videos on high availability, and we've just gone through taking a running Pi server and turning it into a Pi collective. Now we're going to implement high availability on the interface level through what we call failover. Failover is where we can have identical interface instances running simultaneously so that if one was to go down, then the backup will be able to assume the role of primary and continue to send data to the Pi server as if nothing happened. Now what this provides, you can imagine, is peace of mind for Pi administrators. If one interface were to go down, they don't need to be freaking out that there is no data coming in because this backup is taken over and is sending data. So it gives them time to find out what happened, to analyze any issues that were wrong with the interface and get it back up and going. For the users, they should not notice a blip. Hopefully the data stream is continuous enough that there would be no data loss visible to them. And when I say no data loss, there are different types of failover for which you can go from zero data loss in what we call hot failover to some data loss in the time it'll take for the interface or the backup interface to connect with cold failover. We'll go a little more in detail through those as we start configuring. Now we already have an OPC interface running on one machine, so our first step is to install an identical OPC interface instance on a second machine to talk to the same data source. So let's go there. Where I am right now is the primary interface machine, and if I were to pull up Pi ICU, you can see I have an OPC interface configured pointing to my Pi collective and specifically pointing to my primary member of the collective. Now let's go to our new machine. And this is our secondary OPC interface machine. There is no Pi software installed, so like any new installation, we'll need to go through and check that the prerequisites are there. First off, we have the Pi application server, the application server role for Windows 2008. What this does is set up the .NET Framework 3.5.1. That is a prerequisite for our OSIsoft prerequisites. Now let me start installing. I have the install kits already in a folder on the machine. And there's the standalone prerequisites that I'll unzip to the folder here as opposed to the default temporary folder. It's easy to go back to in case something were to go wrong during the actual installation. Okay, so that prerequisite installed, and there is also a prerequisites patch which will install just a newer version of our runtime redistributables. There's all our prerequisites set up. Now what I want to do is first install the Pi ICU interface configuration utility, and then I'll install our OPC interface. See, it's going to install a new version of the Pi SDK 2010 R2, the version of ICU, and the newest version of the Pi buffer subsystem. We'll also configure that today. Now this folder, I only have a C drive on this machine, but if not, you might be looking at a D drive or a different drive than C, where your Pi PC folder is. Since this is the first Pi software installed here, I need to add in the default Pi server. It's called Chestnut, and that's my Pi collective. There's a summary and installs. The ICU install is complete, so my last one to do is the OPC interface. Looks like I missed that. Pretty much everything is installed but the interface and the ICU plugin. During the installation, there's just a warning if you're going from a version that is 2.1.4, 8.0 or earlier, which is probably not going to be the case for most people. Now everything I need is installed. I can pull up ICU and we can start to configure our identical OPC interface instance. There are a couple options for doing that. First, we can create an interface the same way we normally do. Open a batch file, navigate to the OPC interface folder, and then get a bat new file and configure the interface exactly as we did the first one. But since it's identical, couldn't we just copy the batch file from the machine that already has it running? And that's actually what I want to do. I simply want to access that folder on, this is my primary interface machine, ShareP Training. PyPC interfaces, and under the OPCInt is where it would be. So here's my batch file. I'm just going to copy it and bring it over to the local PyPC OPC interfaces folder. Now that I've done that, if I go back into ICU and open that batch file, it loads the interface with the same configuration with the point source, the ID. If we look under OPCInt, there is already our OPC server name that is configured. The one thing you may notice, since we took it from a machine that has the OPC server installed locally, the OPC server node name is still localhost. I'll need to change that to the name of the machine hosting it since it's no longer local. Now with that change, there are DCOM configurations that need to be taken, and that's something I've already done here and set it up so that when I start the interface it should run properly and be able to collect data. But that is one other consideration if you're connecting to an OPC server that is not local to the machine. I'm applying this change to save it. See, the scan classes are all the same. Look at service. I haven't configured PyBuffer subsystem yet, but why don't we do that now? I go to Tools, Buffering, Enable with PyBuffer subsystem. It puts a notice that we need to configure the buffered servers, so it's going to automatically take us there. Where from the drop-down I'll select my default Chestnut Pi Collective. I want to replicate data to all collective member nodes, and there is the fully qualified domain name to each server of the collective. Before I actually start the PyBuffer subsystem or even the interface, I need to first configure trusts for this machine, and you can make it as specific as you'd like, but I need to do that from the Pi server. I'll go back to my primary Pi server, open System Management Tools, navigate over to Security, Mappings and Trusts. Now the reason I was already able to open ICU before without any errors was because I'm logged in as this administrator on the Pi school domain, which has a mapping to PyAdmin. Now the Pi buffer subsystem and the interface do not use that mapping, so I'll need to set up a couple trusts for each. You can see already from my first interface machine I have application specific trusts. What I can do is, since the configurations will be very similar just for different machines with different IPs, I can copy them. So why don't I do that? I'll just copy. Except now I want to change the trust name to Almond, the host name of my secondary OPC interface machine. I know that the IP is 4.192.168.1.4. This will do it for Pi ICU. Let's do that for the rest. You can see I have my OPC PE application name. So now all of these trusts were created and replicated over to the secondary. So either server we connect to, it should be successful. Let's go back to the Almond machine. I apply my changes to buffering, and if I go over to Buy Buffer Subsystem Service and start it, it was successful, no critical errors. You can always verify that by going back to the server, operation, Network Manager Statistics. Go to the most recent connection. There's a PyBuffSS coming remotely from a machine with IP address 192.168.1.4. And we could see how it's connecting using our trust and PyAdmins. I can exit out of this. Now, let's just start this interface, because I want to see if we can first get any data before configuring failover. So I want to clear the cache here. If I go back to service, you see that PyBuffSS was automatically started as a dependency. And what I'm going to do now is create it as a service. That's done. I'm going to open the message logs and start the interface. You can see I'm actually getting some errors. I did realize I forgot to do one more setup. And as part of the DCOM, it requires that a certain user is created on each machine. And that's what I've done here. So I'm going to put in the username and password so that the interface runs as that user. Now I'm typing in the password, and then I'll have to restart it so that it takes that change. So I've put in the proper password now, but before I start it up, what I want to do, just to make sure that we know the data will be coming from this interface, is to stop the one that is running right now on the primary. Now this might not be something you want to do on site unless you're in a downtime, but it's a test that I want to do just for now. So I've stopped the primary interface. I'm starting this up now, and I'm watching the logs as it goes. And once I see it's fully started up, which I see now, I am going to go look at our primary server to see if we're still receiving data for those OPC tags. Just do a current value search. You hit play and we're still receiving data. So we know that the interface on that machine is able to grab from the source and send over to Pi. We're now ready to configure failover. I'll go back. I'm going to stop this interface again and then start back up the primary. Check here, we still get data. Now to configure failover, I want to go under the UniInt tab, and UniInt is our framework for almost all of our interfaces, and that's where failover is built into. So for OPC, it is available, and it probably is available for a good amount of interfaces, but I would always verify in your interface-specific documentation to see if you can set it up and the best practices for it. Now I select failover and choose to enable UniInt failover. There are two phases, phase 1 or phase 2. Phase 1 will rely on the data source in that we're going to write back heartbeat values and status values to the data source, which the other interface will also read. So it's going to know by those tags whether or not it should take over and start sending data if one interface is down, or if it should just remain in backup mode. Now the problem with that is that it requires writing back to the process control side, which is almost always frowned upon. So that brings us to phase 2, where instead of writing back to the data source, we write to a synchronization file whose path we specify down here. Now this file typically can be on a file server, some separate machine if you want. It can also be on the same interface machine as we're going to set up today. It just needs to be in a folder that is accessible by both machines. So you need to make sure that security settings are proper and that it's a shared folder that can be accessed. So first, it automatically puts our interface that we're currently on, which is the primary on ShareP training. And under the second one, I'm going to browse, and it automatically will find any identical interface instance. So it found the one on Almond. I'll set that. Failover ID is 1 for the current one we're on, and 2 for the new secondary interface. Now UFO types, cold, warm, and hot. I discussed that hot is no data loss, cold is the most data loss out of them, and a little bit about why. What cold will do, it's only really useful if your OPC server can support only one client at a time. And the backup interface will not make any contact with the OPC server until it becomes the primary. So that means it needs the time to connect to the OPC server, to create groups, add the tags to groups, and then start advising. So in an interface that has tens of thousands of tags, that could take a while. And that is the data loss aspect of it. Although that process will get started as soon as the interface detects the other is down. Hot, both interfaces are always connected and always having tags and groups already, so it'll just start collecting data as soon as it flips over. Now warm, and today we're going to set up what we call warm 2. Warm 1, connect only, is just what it says. It's only connected, but it hasn't created groups or added the tags yet, so it'll need to go through that process. Warm 2 has created groups, but it hasn't added tags. And then Warm 3 has everything done except for starting to advise the tags and see when new data is collected. We're going to go through Warm 2. Now a synchronization file path, it already gives us a name. I'm just going to select a folder, and I'll keep it right where the OPC interfaces folder is. So I'll make a new one there just for our failover sync synchronization file. So I want to apply my settings now. Nothing's been done. None of this takes effect until a restart. But before I do that even, I need to go configure this same setup on my secondary interface. Excuse me. So I'm back here, and I'll go to my Failover tab, enable it, and select Phase 2. So here you can see it has the Failover ID 1 set to this instance, which is not correct, but what we're going to do is browse and find our other one on ShareP Training. It notices that there is already Failover configured with Phase 2. And once I bring it in, it says it's already configured. Let's use the settings that are already there. So now it put ID 1 to ShareP Training and ID 2 to Almond, just as it should. I'll have to configure the rest of it just as I did before. I want to select the same synchronization file path on ShareP Training. So I'll just navigate there. The setup is very close to finished. What we see here now are a set of tags that have a status of not created. Let's look at some of them. State 1, device status. These are UFO tags that are whose values are being written to the shared file, and each interface is looking at them to know what to do. So heartbeat 1, heartbeat 2, those are the most important. These are counters that go from 1 to 15, and as soon as it stops for a certain period of time, either 5 or 10 seconds, the other interface notices this and it assumes the role of primary. That is how we know when to fail over. So we need to create these. You only need to create it from one of the interfaces, and it'll create it for all the tags. But if I select create all points, it brings a message that, okay, first we need to create a digital state set, because these tags will use certain states, and it's going to create that for us if I select yes. Here are the list of states in that set. Backup no data source, backup, primary, transition for when it's in the process of taking the role of primary. Now we're created. If we go back to ShareP Training, if I refresh, you see it's created here as well now. Let's test that failover works now. That means I need to restart the primary so that it now takes these failover changes. And as I do that, I'll bring up the message log. Move it over here. I'll point out a couple important messages along the way. If I scroll up a little bit, we see right here that the interface is attempting to assume the role of primary. So it's starting, seeing that there's no interface. Now we look, it is in the primary state and actively sending data to Pi. There is no backup interface available. Let's start the backup interface. I'll just play it right away. I already had the logs open. And if we go now back to the primary, there was a backup interface available. At first, with a communication error to the data source, that was because it was still starting up. But then, you see it became fully available and ready to collect data. So, if we go back to our primary Pi server, data is still being collected. What I want to do is bring in those new failover tags. So if I search for all OPC again, we now have our UFO tags. The states, the state of 1, which is our primary, or which was the one on ShareP training, is our primary, and the other is our backup. We have heartbeat values here. Device status of 0 is good. It means it's able to communicate. I'm refreshing just so I can see some of the heartbeats updating. Let's force a failover now. Now to force a failover, I can just stop the primary or restart. I'll stop the primary because sometimes it may restart so quickly that we're unable to see the failover take place. So let me stop it. And let's watch the tags change. It shows the primary is off when the backup is in a transition state. So it's waiting to see, is the primary really unavailable? Let's give it that time. It saw that it was still off. It's now primary. We haven't missed a beat with our data. And if I start the primary or the former primary back up, it'll now take the role of backup in the failover configuration. Backup no data source, and backup. Now the most important thing throughout that time was noticing that all of our tags up here had not stopped moving and updating every second. That was our settings for the scan class. I'm only looking on the primary PI server, but we can even look on the secondary and see all the same data. So search all OPC tags, bring them in, and you see values update. So that is how we configure high availability, first on the PI server level in creating a collective, and then on the interface level with failover. I hope you enjoyed it, and I hope you have success in setting it up on your own machines. Thank you.